Welcome to GMS to Davangere. Today we are going to study the characteristics of SCR. Experiment number 1, Static Characteristics of SCR. Theory: the static characteristics of silicon control rectifier describes the relationship between the anode to cathode voltage and anode to current under the steady state conditions. An SCR has three modes of operation: reverse blocking, forward blocking, and forward conduction mode. In the reverse blocking mode, when the cathode is made positive with respect to the anode, the SCR behaves like a reverse biased diode and also only a small leakage current until the reverse breakdown occurs. In the forward blocking mode, the anode is positive with respect to the cathode. Apparatus required: SCR module, ammeter, voltmeter, DC power supply, and patch cards. This is actual circuit diagrams. We have RPS of 0 to 30 volts. We have SCR, and we have another voltage to anode to cathode voltage source, that is 0 to 30 volts. And we have SCR having the terminals anode, cathode, and gate. For the gate, we are given the supply of VGK, and for anode to cathode, we are given a supply of VAK. Procedure: make the connection for the given circuit diagram. To switch on the supply until the initial, keep the V1 and V2 at minimum positions and set the load potentiometer RL in the minimum positions. We have to adjust the gate current to around 10 milliamperes and vary the V1. Set the load potentiometer RG in the minimum position. Adjust the gate current say around 10 milliamperes by varying V1 and note on the VK readings for every 5 volts and tabulate the readings. So these are the readings for minimum value of VK. 0.7 the current is 2 milliamperes, 0.7 10 milliamperes, 0.6 17 milliamperes, 13.4 0.01 milliamperes, 15.4 0.01, 17.4 0.342, 0.7 0.91. So these are the VI characteristics for different value of gate current IG1, IG2 and IG3. Initially the breakdown voltage will occur at this point. After that the voltage VIK will goes to almost 0.7 volts and anode current start rising. So during the time we can have the holding and latching current in the region 3, and this is the reverse breakdown characteristics of the SCR in the third quadrant, that is region 1. This is the actual graph. Results: VI characteristics of SCR is determined. Thank you. I am Anil Kumar TRB, Assistant Professor, Department of Electrical and Electronics Engineering. Today we are going to learn the VI characteristics of silicon control rectifier, that is VI characteristics of SCR. So this is actually the SCR unit. So in this we have to follow the procedure. According to the procedure, first we have to turn on the unit. So once we turn on the unit, we have to keep the RG, that is the gate resistance and anode resistance, should be in the minimum position. So it is already set. Now we have to turn on the VAK voltage. So once VAK we have to set to the 15 voltage. You can observe here the VAK is going to be rise. This 4.5, 7.2. We have to set to the 15 voltage. Okay, now it is set to the 15 voltage. Okay, now we have to turn on the VG, that is the gate current we have to rise. So this is IG current and this is anode current. So once we have to rise the IG current, we need to check what is the gate current in terms of milliampere. Okay, 6.90. Now voltage is getting reduced here, VAK voltage. It is around 6.9. It is become 0.7. Now we have to record the value of IG current, that is 7.1 milliamperes. 7.1 milliamperes. Now we have to off this and reduce voltage back to 0, that is VAK voltage. Again you have to turn on the VAK. Now we have to observe the VAK voltage at what value of anode current will rise. That is means SCR going to start conducting. So 2.2 volts it is 0. Next 2.9 it is 0. So 8 point it is 0. 9.8 it is 0. 10 point it is 0. 13.3 it is 0. 16.8 it is 0. 20.20, 20.2 it is 0 anode current. 23
0.3 it is 0, 26 it is 0, 31, the anode current is 71 milliamperes. Now anode current is going to start conducting, that is the SCR going to start conducting now. Then we have to check the tabulate the values of VAK versus IA. Now we have to tabulate the VAK versus IA current. So that is for 1 it is 0 milliamperes, for 30 it is 0 milliamperes, for 31 it is 15 milliamperes, for 0.7 it is 20 milliamperes, for 0.7 it is 25 milliamperes. After taking the readings of VAK versus IA, we have found out the holding and launching current is IL is 35 milliamperes and holding current is 28 milliamperes. So thank you.